So, a special case in this case of writing a vector R in terms of any two vectors A and B, then if the magnitude of all these three vectors A vector, B vector, and the vector R which we want to write, all these have equal magnitudes and vector is perpendicular to vector B, then in such case we can write R vector as the projection of A along R, which is A dot R cap to R cap plus B dot R cap into R cap. This is how we can write this R vector, which can be also written as A vector cos alpha plus B vector not like that. And this can be written as B cos beta. The main thing is to remember this, that the projection of A along this line, this vector, and the projection of B along this vector, adding both, we will get this R vector. And also we can write A R vector as the A cos alpha, A vector cos alpha plus B vector cos beta, where these are the angle they made with each other. And also we know that alpha plus beta is equal to 90 degree, so it gives A vector cos alpha plus B vector sin alpha. So R vector can be written as A vector cos alpha plus B vector sin alpha, simply like this. R vector into cos of angle between these two. So this is how we will write R vector as the sum of these two vectors. One example for it can be this was an important thing. One example of it can be, let's say there is a unit vector r cap making theta angle with x-axis, then how to write the r cap? We can simply write r cap as there is a unit vector I cap here and there is a j cap here. There are two unit vectors, all these three vectors j, I, r are magnitude 1 and j and I are perpendicular. So I can say that I can write r cap as I vector cos theta plus j vector j cap vector cos of 90 minus theta. This will become equal to I cos theta plus j sin theta. So r cap can be written as the sum of these two vectors like this, according to what I told. So this is what it is. Now moving ahead, we just need to keep in mind that if A vector's magnitude is equal to B vector's magnitude, the case was A vector's magnitude is equal to B vector's magnitude is equal to R vector's magnitude and A vector perpendicular to B vector, then it gives R is equal to A vector cos alpha plus B vector cos beta, where this is A vector, this is B vector with same magnitudes, this is, let's say, R vector again with same magnitude, this is beta angle and this is alpha angle. Then we can use this method to write the R vector. Now going ahead, we have talked about components. Now talk about chain rule of vectors, how to add many vectors or write a vector with respect to other. I call it chain rule for vectors. I don't know what can. Let's say there is a vector. We can use it for any vector like acceleration or position or velocity or any type of vector. If I want to write vector 1 with respect to 4, I can write it as vector 1 with respect to any origin plus vector O with respect to 4. Means this is I am writing vector 1 with respect to any other vector. Writing a vector with respect to other vectors. So the chain things means I linked this to origin, then the origin was linked to 4. So adding both will give 1 to 4. 1 to 4 will be linked. I jumped jumped from 1 to origin, then origin to 4. So I finally reached 4. So this is what it means. And I can also write it as vector 1 with respect to any other vector, let's say 2, then I can write 2 with respect to 3, then I can write 3 with respect to 4, and here I can see I jumped from 1 to 2, then 2 to 3, then 3 to 4. Overall I can say that I jumped from 1 to 4. So this is the 1 to 4 vector I need. Now this vector can also be written as a1 with respect to origin minus a4 with respect to origin. So this is what relative velocity things and position and acceleration, whatever we used to write, we can simply write from this chain rule. It's easy to remember. So this was chain rule and chain rule. Let's say example, we have let's say there is a river flowing with a velocity vr with respect to ground, and there is a boat moving with a velocity, let's say vm with respect to river. Now I want to find what is the velocity of this man with respect to ground. Then I can simply write it as velocity of man with respect to ground is velocity of man with respect to, let's say, r. Then I need to write r with respect to ground, which is also given. So this will be the formula for velocity of man with respect to ground. M to r and r to g. Simply it means I jumped from m to g. So this was the chain rule stuff. Now the fifth thing is polar vectors, polar coordinate system. Polar coordinate system, which is in 2D, 2 dimensions, and it uses r and theta. So position is given by r and theta, where position is given by r and theta, where r is distance from origin and theta is angle made by r vector with positive direction of x-axis. So I can draw it as, this is r vector, it has length, let's say r, or you can write it as r. So I can write it as r or r. We can use any of these r symbols. This is the distance from origin, and this is the angle made with x-axis. So this is a particle with particle at point B with location theta angle with our x-axis and r distance from origin. Now this r vector can be written as r cap or r cap. This is the distance from origin and this is the unit vector of this r vector. Now how to write r vector, r cap unit vector? We know that if there is a unit vector r cap, we can write it as, if it makes theta angle, let's say this is a unit vector r cap, since it makes theta angle here, it will make theta angle. The r cap vector and r vector are in the same direction, so this will also make theta angle with this x-axis. So this is, let's say, I cap, this is j cap. All these are of same magnitude, so same magnitude, and I cap is perpendicular to j cap. So I can write r vector as simply I cos theta plus j vector j cap cos 90 minus theta, which is sin theta. So this is how I can write r cap vector. Now in case of polar, there is another vector which is called theta cap. Theta cap is equal to unit vector perpendicular to r cap. So this is the r cap vector, let's say, then theta cap will either point in this direction or will point in this direction. If the particle is moving in this direction, then theta cap will be taken in this direction. If the particle is moving in this direction, then theta cap is pointing in this direction. Theta cap points in direction of motion. So to choose which direction we need for theta cap, we will use this point, that theta cap points in the direction of motion. Let's say the particle is moving in this direction, then theta cap will be taken in this direction. If the particle is moving in this direction, let's say in this direction, then theta cap will be taken in this direction. Now theta cap can also be written as, like, this is r cap, theta is the angle with x-axis, I cap, this is j cap, and theta cap will be this perpendicular to this r, so this angle will be theta. We can take any minus I vector here, these to make 90-degree angle with each other, then and all three have same magnitude, then theta can be written as j cos theta minus I 90 minus cos of 90 minus theta is sin theta. So these are the two formulas in polar coordinates. Now the important thing here next is that dr by dt is equal to differentiating I and j are constant, so differentiating cos we will get iota minus sin theta. Theta can be variable, so theta will give d theta by dt, which is d theta by dt. And now we will say that d theta by dt is equal to omega of line joining particle point and origin. So this is what omega means. Omega is the angular velocity of the line joining point and the origin. So यहाँ पे हमारे पास differentiating this will give j cap cos theta omega. We will write this as omega. Now this, if we take omega common, then this value will becomes this. We will say that this becomes omega theta k, because minus I sin theta and j cos theta both sum will give theta k. So I can write this simply as omega theta k, and d theta k by dt, differentiating it, will get j k minus sin theta omega minus I cos theta omega, that is equal to, taking omega common, we will get negative of I cos theta j sin theta negative of r cap. So we can write this as simply minus omega r cap. So this is the derivative of these two, unit vector of position and theta cap vector. And theta cap is not any angle, it is only a unit vector that is perpendicular to r cap. That's all we need to think when we think about theta cap. So these are two very important equations. Now moving ahead, we got some important things about polar. Now next thing is rotating vector differentiation with respect to time. And polar, in case of polar coordinate system, we can write, let's say there is a vector, let's say a, and it is taken, we are taking differentiation of a vector with respect to time, then we can write it as magnitude of a into a cap divided by time. Now this will give a dA by dt plus a dA by dt. Now this is how we will write the vectors equation. Now this vector, let's say the vector is rotating with omega angle. If any vector changes direction then we can say that it is rotating also. Let's say the vector is rotating with omega angular velocity, then we will say that it is a omega theta cap, where theta cap is a direction perpendicular to, let's say this is a vector and it is rotated like this. This was a initial and it was a final. It rotated like this with omega, and then theta cap will be pointing in this direction, and this is a very small angle d theta. So it is rotating like this, then theta cap will be pointing in this direction and a cap will be pointing in this direction. Now this is a omega theta cap plus a cap. dA by dt, which is the rate of change of magnitude of a vector. This can be written as omega cross A plus a vector dA by dt. This will be equal to this. This can be simply memorized, and I can give an example for this. Let's say there is a vector rotating with, there is a vector A rotating with omega, then its theta k will be pointing in this direction, I k points in this direction, theta k points in this direction. Now if it is rotating in this direction, then theta k omega will be pointing in this direction upward, and A is pointing in this direction, then omega cross A will be in this direction, which is also the direction of theta k. So these two directions are same. Now, so I will take a special case of this vector of constant magnitude rotating with omega vector rotating with omega angular velocity in space. Then dA by dt can be written as, then the differentiation of vector A with respect to time can be written as, since the magnitude is not changing, we will take the magnitude out and we will get here dA cap by dt, that will be equal to a omega theta cap, and we can simply write a dA by dt is equal to omega cross a vector. This is what it is. This is the main formula we need to remember. The dA by dt can be written as omega cross a when it is of fixed magnitude. Then at any instant of time, the angular velocity is omega, and taking cross of this with a vector will give the rate of change of a vector with respect to time. Example can be taken as, let's say there is a uniform circular motion. This is with radius r. There is a particle moving in a circle. So dr by dt is actually equal to velocity, and dr by dt can be simply written as omega cross r. Since the magnitude of this radius vector, the radius of this circle will be fixed, so we can use this formula that dr by dt is equal to omega cross r. We know that this is the formula of velocity also of this particle. Now if I want to take the dv by dt of this uniformly moving particle, it has v speed is constant here, the magnitude of the v vector is constant. Again we can use this formula, and we can say that it can be given by omega cross v, and this is also the formula of acceleration. This is a centripetal acceleration in this circular motion. So acceleration of this body will be, point will be omega cross v, and the velocity will be omega cross r. When the radius is fixed, speed is fixed, and rotating with omega angular velocity. Simple. So now one more thing on vectors is, let's say we have three vectors. A vector, B vector, and C vector. Now first question is that if we are given that a vector is known, comma direction of B is known, that is B cap is known, and we are given that A plus B plus C, sum of all three vectors is equal to 0. Then we are asked what is the value of B vector comma C vector so that C is maximum, or we can say that it is asking what is the value of B vector, or it is asking the magnitude of B vector so that the value of C is maximum. So how can we solve this? This can be simply solved by, first we have a fixed vector, we need to take the fixed vector and this is a fixed vector. Let's say this is a vector here, and take a line. Let's say this is the line of B vector B cap. This is a line along B cap. The length of this vector is not defined, can be anywhere. Now we want to find that the sum of this B vector, A vector and this C vector, sum of B vector, A vector, C vector is equal to 0. B vector plus A vector plus C vector is equal to 0, as we can see. Now this C can be this line or this line or this line, it can be any line. So for the we have to find minimum value of C, so for the minimum value of this C vector we need a perpendicular line from this line, from this B vector joining this point. So in this way we can calculate that, let's say this is the angle theta, we can find the angle theta using B cap and A cap, and if after knowing the angle theta between them we can tell that the magnitude of C is minimum, or the magnitude of C will be equal to A sine theta, magnitude of A into sine theta, and the magnitude of B vector will be equal to magnitude of A cos theta. So in this question we knew that what is the magnitude of one vector, we knew the magnitude of one vector, we knew the direction along which the second vector exists, and we had to find the third vector so that its magnitude is minimum. So B vector lies along this direction. Let's say if it is along this direction, then this will be C vector from this to this. If the B vector is pointing in this direction, then obviously we cannot take simply this B vector, we need to join this is our A vector and A minus B vector makes theta angle. Now the B vector, if B vector is in this direction and A vector is in this direction, this is the angle between them, let's say theta, and we want to find an angle A vector C such that it gives again a 0 value. So we will draw it like this. We will draw a line from this point and this will become a vector and this will become the b cap in this direction. And say from a plus b a b c. Never mind. So this b vector points in this direction, b vector, then a vector, then c vector gives 0 here. That's how we will try to do when such type of problem occurs, where we want to find the, we know this vector, we know the direction of this, and we want to find this minimum value, so we can use this way. Another case is if a is known and b's magnitude is known, and we want to find, we have given that a plus b is equal to c. Now we want to find angle of b. We want to find b cap, that is the angle b with a. We want to find the direction of b. Let's say this is a vector and we are given that a plus b is equal to c vector, so that c becomes maximized. So let's say this is a b vector, its direction is not fixed but its magnitude is fixed, so it can point in any direction and the c will lie. So it can be like b vector can be here, b vector can be here, b vector can be here, and the resultant will be, c vector will be this or this or this. So these will be the values of c vector. So in order so we want to actually maximize angle between this c vector and a vector. This angle is theta. Maximize angle between c and a. So we want to maximize angle between c and a. The question is that we know a vector, we know the magnitude of b vector, we don't know the c vector and the direction of b vector, and we want to maximize the angle between c and a. So in this case we know that to get the maximum angle, this will touch at here, making a tangent line. So if it is tangent, then this will be a 90-degree angle and this will be b, this is a, then we can say that this angle is equal to, this is hypotenuse, this is base, then tan theta is equal to, or we can say this is perpendicular, this is perpendicular, this is hypotenuse. We will say that sine of theta is equal to b upon a, the magnitude of p upon a. This is the case for maximum angle. For maximum angle between c and a, we will get this value. Next topic is omega of line. Angular velocity of a line, that is omega line. So when we are asked about the omega of a line, let's say there are 2 points A and B. Line joining A and B points. So we want to find the omega of the line joining A and B points. Let's say this point is moving with some velocity VA, it is moving with a velocity VB, and this is the line joining A and B, and this line's length is, let's say, R. The length of this line is, let's say, R, and now we want to find the omega of this line. That will be equal to omega of AB is equal to omega of BA. Since the line is same, whether call it AB or BA, their rotation will still be same. Either find with respect to A or find with respect to B, the omega of the line will be same. Now the omega will be simply the velocity component perpendicular to the line, velocity of A with respect to B perpendicular to line divided by R. Or we can say we want to find velocity of A with respect to B perpendicular to line's magnitude, that is equal to velocity of B with respect to A perpendicular to line's magnitude divided by R. This is the magnitude of angular velocity, where VA perpendicular, this can also be written as, this is actually the relative velocity along this perpendicular to the line. Let's say this is x-axis, this line is x-axis, and this perpendicular is y-axis. Then this will become velocity of A with respect to B along y-axis divided by R, that is equal to velocity of B with respect to along y divided by R. So this is what it looks like. And if we solve for this case, let's say this angle is theta A and it is theta B here with this line. These are the acute angles. Then we will get velocity of B in this direction will be VB sine theta B, and this direction, and this particle is moving in this direction, so velocity of B with respect to A will be VB sine theta B, and since it is moving in the opposite direction, it will get added VA sine theta A. The perpendicular velocities, we are taking the relative perpendicular velocity divided by R, taking the magnitude. So this is how we will calculate. So it is simply the relative velocity of perpendicular velocities divided by length between them, that is R, the distance between those 2 points. So this is the formula of omega, angular velocity. Let's take example. Example is like, let's say there is a point here, this is origin and this is point A here, let's say point B here. So omega of point P with this point P and O line, let's say this is rotating with, it is moving in this direction with v velocity. Let's say it is moving in a circular motion and it is moving with the velocity v. So the velocity will be perpendicular to the line joining both, and let's say the distances are, then the omega will be equal to v. This, it has zero velocity, so we will simply take v divided by r. This will become the omega in this case. So v sin theta will be v1, so v minus, it is zero velocity, v minus 0 divided by r will be v by r, or we can say this is vp by r. So this is the equations of omega.